Hello, on behalf of Sigma-HSE, thank you for joining us for our webinar today. We want to give everyone an opportunity to jump into the session, so we will get started in about 2 minutes. Hello, thank you for joining us today for our webinar on Hazard and Operability Study and Layer of Protection Analysis, also known as HAZOP and LOPA. I am Mark Yukich, U.S. Technical Development Manager at Sigma-HSE, and I will be your host today. I have nearly 10 years of process safety industry experience. That includes combustible dust, flammable vapor, and chemical reaction hazards, and steps to mitigate those hazardous materials in process. I enjoyed taking the time to understand the pain points for our customers related to process safety. If we don't have the option to assist, I want to ensure we hand you off to a team we trust to bring value to your safety team. Please feel free to contact me should you ever need any assistance. Sigma-HSE is a global engineering firm with technical experts supporting companies around the world to provide actionable solutions to protect, enhance, and optimize their process. We provide actionable risk assessments and testing solutions so you can focus on what really matters: protection for your people, business, workplace, and environment. In this webinar, we will discuss the Hazard and Operability Study, HAZOP, and Layer of Protection Analysis, LOPA. We will cover key elements of HAZOP-LOPA and learn why the LOPA methodology excels at assessing the likelihood of various risk scenarios. We will have time for Q&A at the end of the session. Feel free to add questions to the questions section during the training, and we will address those questions at the end of the program. Doug Gruder will be our process safety consultant leading our discussion today. Doug, I will turn it over to you.
Thank you, Mark. My name is Doug Gruder. I have a total of 43 years of manufacturing experience, 13 years in direct hands-on process safety management and EHS. Also, I have another 14 years in process engineering and operations management and 8 years in process control. The purpose of this presentation is to give you an overview of HAZOP-LOPA and explain to you how we get to the likelihood using LOPA and the purpose of it. As in any PHA study, the purpose is to identify and mitigate risks. Then what we need to do is highlight those risks to management and the operators and get them into a risk action plan for the site so that they can be prioritized based on all the other demands that are on a site and taken care of in a timely manner. The strength of combining LOPA with HAZOP is that it will have right off the bat. And this depends quite a bit on tribal knowledge of the team. And you can see an example of the likelihoods that are listed here, going from extremely likely to extremely unlikely, which is a very subjective determination. In a HAZOP-LOPA, the likelihood is determined by the probability of failure on demand of both the unmitigated risk analysis and the mitigated risk analysis. And we'll go into that in a bit more. First, like I said, there are two parts to a HAZOP-LOPA. What to do before the team meets and what to do during the team meetings. The very first thing that the facilitator should do is pull together a team. You must have at least an operator familiar with the process, a technical person familiar with the process, and a maintenance person. You should also have an EHS representative because you'll be evaluating things according to codes and standards. Another thing you have to do is collect process safety information, and this is very important. So you certainly want to have P&IDs so that you can determine the nodes that you'll be going through. You want to know your control system and any interlocks that are available, as those will be used as safeguards, and your equipment specification and operating conditions. And operating conditions, both safe upper and lower boundaries, are important to have going into the HAZOP, because you're going to use these during the team meetings to develop credible scenarios using guide words such as more, less, flow, and pressure. You need the safe operating limits to know when you're falling into a more flow or less flow situation. Then you're going to determine a severity, how bad the result of the consequence is. And then in the LOPA section, you'll determine the likelihood. And that's done by determining the unmitigated risk and the mitigated risk and adding in your safeguards or your independent layer of protection. And we'll go into that in more detail. So you want to determine what the risk to the company is. And that's the combination of the severity and the likelihood. And then you'll look at what the company's risk criteria is. And if the risk is higher than that, you'll want to identify recommendations to bring it back down into an acceptable range. Next, I'm going to talk a little about the material in the form of an example. And our example here is a binary distillation column of alcohol and water. Alcohol will come off the top of the column and the water will come out the bottoms. In this scenario, the overhead valves are closed and the bottoms flow cannot keep up with the material coming in. This results in the safety devices, the process safety valves, being flooded. The consequence of the flooding and overpressure of the column results in the column failing, releasing alcohol vapors, and resulting in a vapor cloud explosion and multiple fatalities. So using this example, the first thing we're going to do is develop the scenario. So the deviation is high pressure in normal operation. The cause is no vapor flow out of the top of the column due to the manual block valves being closed. The consequence is that the pressure in the column exceeds the MAWP of 75 psi. The column ruptures, releasing alcohol vapor, which finds an ignition source, resulting in a vapor cloud explosion. So to go over this, the cause is the event that starts the scenario, and the consequence is the result of that happening. Next, we'll go into determining the severity, which is the next step. The severity is the outcome of the event. And we have to remember here that we're not adding any layers of protection. Often during a HAZOP, you'll hear participants say, that really cannot happen because we have this or that interlock or this safety, or the operators know better. Well, those are layers of protection and will be taken into account when determining the unmitigated and the mitigated risk likelihoods. Right now, we're just going with the pure severity without any layers of protection. And the severity can be an injury, environmental insult, or monetary. So here you see the consequence category is an injury with a severity of 6, which is a multiple fatality. So next, what we're going to do is take into account the likelihood of the event occurring. As said previously, the LOPA methodology uses the combined probability of failure on demand to determine the likelihood. Doing that, you'll determine an unmitigated risk likelihood using the initiating cause, any propagating or enabling causes, and the conditional modifiers of probability of ignition and worker present. Then we'll determine the mitigated risk likelihood, where we'll take credit for our layers of protection. Combining the two, we will come out with a finally likelihood for the event being studied. Going into each of these in a little more detail, the initiating cause, the deficiency that started the scenario could be human error, an instrument or equipment malfunction, a leak, or external events. Next, we'll talk a little bit about propagating cause. And the propagating cause is an event that must occur in addition to the initiating event for the scenario to take place. And here, we have to be careful to avoid double jeopardy. The following guidelines are what should be used. 2 concurrent human failures is credible. A single equipment failure with a human failure is credible. But the simultaneous failure of 2 or more independent pieces of equipment may not be credible. An equipment failure or human failure in combination with an external event may not be credible. And the simultaneous occurrence of 2 or more independent external events is not credible. So keeping that in mind, the next unmitigated risk analysis component is the enabling event. And the enabling event is something that helps the scenario to move along, but only happens in a certain percentage of time during the operation. Some of the examples would be a startup or shutdown condition, a specific step in a batch operation, weather conditions like icing or tsunami, or a hidden failure that has no consequence until the other event, the initiating and propagating events, occur. Things of this nature would be a check valve failure or an interlock malfunction. Now we go on to some conditional modifiers, the probability of ignition. In our scenario, the alcohol vapor finds an ignition source. So the definition for probability of ignition includes 2 probabilities. The probability that an ignitable mixture is created, and the probability that the ignition source has sufficient energy. Some things that should not be taken into consideration during determining the probability of ignition would be secondary containment to limit the spread of liquid, drainage, your classified area and the equipment within it, and bonding and grounding. These will be considered under the safeguards in the mitigated risk probability section. Probability of worker being present. If you're going to have an injury, there has to be a worker present for that to happen. Typically called probability of presence on demand. And there are a number of guidelines around this conditional modifier. So to summarize, The unmitigated risk likelihood has to do with the probability of a human error occurring, a propagating cause, if any, and an enabling event with the probability of ignition and a worker present. You can see in this example, we have -2 on the initiating cause frequency and a -1 on the propagating. Which leaves us with an unmitigated risk likelihood of 3. So our severity started out as a 6. We subtract 2 for the initiating cause frequency, subtract 1 for the enabling event frequency. Now we're going to move on to mitigated risk and safeguards. But before we do that, we should review what an independent layer of protection is, because any safeguard has to be independent from any other safeguard. And that means that there are no common cause failures. So a layer of protection should be included in the mechanical integrity program and have a preventive maintenance procedure. If it does not, you cannot take credit for it, but should write a recommendation to include the IPL in the MI program and have a maintenance procedure to address it. The mitigated risk likelihood, like I said, are your safeguards. You can see there are 2 listed here. One is a basic process control system interlock, and the other is a hardwired interlock. The basic process control system interlock goes through the DCS, is initiated by a sensor, the action is determined by the logic solver, and the final control element will either close a valve or it will stop a motor. That's kind of an explanation of an interlock going through a control system. The other one that we have credit for is a hardwired interlock, which does not go through a control system. Since both of these are separate and not subject to common cause failure, we can take credit for each of them, which would give us another -1 credit for the BPCS interlock and a -2 credit for the hardwired interlock. Now we can combine both the unmitigated risk and the mitigated risk to get a final risk. So you remember the severity was a 6. We had in the unmitigated risk likelihoods a -3, and we have another -3 in the mitigated risk likelihood with the 2 safeguards shown above, which will bring us to a mitigated risk of 0. The mitigated risk of 0 falls right on this horizontal line on the risk matrix and would be acceptable. There's quite a bit of discussion in companies as to what an acceptable risk is. It could be a 1. It all depends on the company's risk criteria. But 0 is good for this example. As I said, the company's risk criteria will also determine how quickly the recommendation should be implemented. We can have a high risk ranking, which in this example is greater than or equal to 2, a medium, which is 1, and a lot of times a medium can be deemed to be all right if it's as low as reasonably possible, or hour. Anything below a 0 is acceptable, usually, and those things can usually be done fairly quickly. So your recommendations, if the risk is above the company's risk criteria, then we have to make recommendations to reduce the risk. And the actions should be put into the plant action database so they can be prioritized as to severity and mitigated according to the company's capital project funding. A lot of these recommendations will take capital expenditures. It's up to the facilitator and the team in a company to highlight the importance of getting these things done. I'd like to thank everybody for their time. And with that, I'll turn the presentation back over to Mark for any questions.
Thank you, Doug. I appreciate it. If you, once again, if you have any questions, feel free to add them to the questions section on the right, and we can get an answer for you. And Doug, looks like one question in here is, it says, it appears both IPLs use TCV 362 to take action to stop the steam, and asking if that is independent. Not sure if that was related to we'll skip to the next one, Doug, because I think they might have had to do with something internally. So Doug, can you expand more or provide any examples of what would be considered tribal knowledge?
Tribal knowledge is usually undocumented knowledge that a number of people in the operating facility will have. They also, people know about it. It's not documented, but they may know how they go about fixing it on the fly in the plant. So it's a collective group of knowledge that's usually undocumented, and a relatively small group of people know about.
Okay, thanks, Doug. Another question here is, how do you decide when to stop at a HAZOP analysis versus progressing into a LOPA? So what specifically triggers indicate that further risk quantification is necessary?
Right, and that all gets answered by the company's risk criteria. Some companies will LOPA anything above a severity 3. Some companies will LOPA everything to reduce the risk as much as possible. If you don't LOPA things below a 3, you will be stuck at a risk ranking of 2, and that may not be acceptable to the company. So it all goes back to the company's risk criteria.
All right. The question that says the hardwired interlock that uses the same control valve, should there be independent valves utilizing different IPLs?
Yes, there should be. That makes them independent. Typically, there'll be two valves in series, and one will be hardwired, as in this situation, and not go through the logic solver. The other one can go through the logic solver.
And another question here is, how do you ensure that the chosen independent protection layers in LOPA are truly independent and effective? Can you think of an example where that was challenging?
No, I mean, these IPLs should be tested. Typically, it's on a yearly basis during a shutdown, but you need to test the whole system to make sure it's working. And that will also let you know that it is independent of anything else going on in the system.
All right. Well, it looks like that's it for our questions. Once again, thanks, Doug, and thank you all for joining us for our discussion today covering HAZOP and LOPA. Should you need any assistance with testing and/or process safety support, please feel free to contact us at info-us@sigma-hse.com. We look forward to being a resource to you, and once again, thanks for joining us.
Thank you, everyone. Have a great day.